Hey viewers, this is Devinder Kaur and welcome to my YouTube channel, The Enlightened Room. In this video, we're going to continue our topic Trends in Modern Periodic Table by studying the metallic and non-metallic character and the variation of chemical reactivity. Okay, so let's get started. First of all, we're going to study about the metallic and non-metallic character. In this, generally metals possess 1, 2 or 3 electrons in their respective valence shells, and thus they have a strong tendency to lose these electrons to form positive ions. Therefore, metals are known as electropositive elements, and the metallic character is also called electropositive character. Now, on the other hand, non-metals generally have 4 to 8 electrons in their respective outermost shells, and thus they have a tendency to gain electrons to form negative ions. Therefore, non-metals are also called electronegative elements, and the non-metallic character is also known as electronegative character. Now let's take a look of metallic and non-metallic character along a period. As we move across a period from left to right, the number of valence electrons increases from 1 to 7. As a result, the effective nuclear charge acting on the valence electrons increases, and hence the tendency of the element to lose electrons decreases. Conversely, it is also true, as the effective nuclear charge increases and the tendency of the element to gain electrons increases. Thus, it can be said that on moving from left to right in a period, the metallic character decreases while the non-metallic character increases. You can take the example of second period here. Here, lithium is the most metallic element, followed by beryllium. The non-metallic character starts with boron and keeps on increasing. Thus, fluorine is the most non-metallic element of the second period. Similarly, in the third period, the sodium, magnesium and aluminium are metals. The properties of silicon are between those of metals and non-metals. Therefore, silicon is known as semi-metal or metalloid. The next elements, phosphorus, sulfur and chlorine, are non-metals. In other words, metallic character decreases from sodium through magnesium to aluminium. Silicon is a metalloid, while the non-metallic character increases from phosphorus through sulfur to chlorine. So generally, it can be said that the most metallic element lies on the extreme left hand side, while most non-metallic element lies on the extreme right hand side of any period. Now let's take a look on the variation in a group. On moving down in a group, the metallic character or the electropositive character increases. Now let's take an example. When we move down alkali metals of group 1 of the periodic table, the metallic character increases from lithium to francium. Thus in group 1, the lithium is the least metallic element, while francium is the most metallic element. Conversely, on moving down a group, the non-metallic character or electronegative character decreases. For example, when we move down halogens of group 17 of the periodic table, the non-metallic character decreases from fluorine to astatine. Thus, in group 17, fluorine is the most non-metallic element, while astatine is the least non-metallic element. Now, the reason behind this is that as we move down a group in the periodic table, the atomic size gradually increases. As a result, the force of attraction between the nucleus and the valence electrons decreases. Thus, the tendency of the element to lose electrons to form positive ions increases, and hence the metallic or electropositive character increases as we move down the group. Now, let's take a look of a variation in acid-base character of oxides or hydroxides along a period. Now, it is very well known that oxides of metals are basic, while the oxides of non-metals are acidic. Therefore, as we move from left to right across a period, the basic character of the oxides or hydroxides decreases while their acidic character increases. Now, let's talk about the chemical reactivity. All the elements in the periodic table are not chemically equally reactive. Some are more reactive than the others. So, the chemical reactivity of an element depends upon its position in the periodic table, which in turn depends upon its outer electronic configuration, which we are gonna discuss. So first let's talk about the variation of chemical reactivity along a period. As we move from left to right across a period, the chemical reactivity of elements first decreases and then increases. For example, in the third period, sodium is the most reactive element, followed first by magnesium and then by aluminium, while the next element, silicon, being a metalloid, is least reactive of the four. So as we move further, the chemical reactivity increases. Phosphorus is quite reactive, sulfur is little more reactive than phosphorus, while chlorine is very reactive. So the last element of the period, that is argon, being a noble gas, is almost unreactive. Now the reason behind this is based on the outer electronic configuration of elements. The first element, sodium, has only one valence electron, which it can lose very easily to acquire the stable electronic configuration of the nearest noble gas. So it is very reactive element. The second element, magnesium, has two valence electrons, which can lose less easily than sodium, and hence magnesium is less reactive than sodium. The third element, aluminium, has three valence electrons, which can be lost with the little difficulty, and hence aluminium is less reactive than even magnesium. The fourth element, silicon, has four valence electrons, so it has little tendency to lose electrons, and hence silicon is even less reactive than aluminium. Thus the reactivity of these four elements decreases in this order. This is supported by the fact that sodium reacts with water so vigorously that hydrogen evolved catches fire. Magnesium reacts with boiling water. Aluminium reacts with water very slowly, while silicon does not react at all. So as we move from silicon onwards, the chemical reactivity increases. This can be explained that phosphorus has 5 valence electrons and hence needs 3 more electrons, while sulfur has 6 valence electrons and thus needs 2 more electrons to complete its octet. Since it is difficult to gain 3 electrons in case of phosphorus than 2 electrons in case of sulfur, therefore sulfur is more reactive than phosphorus. The next element, chlorine, is even more reactive than sulfur since it needs only 1 more electron to complete its octet. Thus the order of reactivity of phosphorus, sulfur and chlorine increases in this order. Also, argon has 8 valence electrons. Therefore, its octet is already complete and hence it is the most unreactive element of the third period. Now let's talk about variation of chemical reactivity in a group. Well, elements in a group have similar outer electronic configuration, hence they have same number of valence electrons. Therefore, all the elements of the group show similar chemical properties. However, the chemical reactivity of elements varies gradually in a group. First of all, let's talk about reactivity of metals in a group. The chemical reactivity of metals increases from top to bottom in a group. Now, the reason being that the chemical reactivity of metals depends upon the tendency to lose electrons. So, as we move down the group, the tendency to lose electron increases due to increase in atomic size and hence reactivity increases. For example, chemical reactivity of alkali and alkaline earth metals increases down the group. Number 2 is reactivity of non-metals in a group. The chemical reactivity of non-metals decreases from top to bottom in a group. The reason being that the chemical reactivity of non-metals depend upon their tendency to gain or accept electrons to acquire the stable electronic configuration of the nearest noble gas. As we move down the group, their tendency to gain electrons decreases due to an increase in the atomic size. As a result, their tendency to accept electrons decreases and hence the reactivity of non-metals decreases as we move down a group. You can take the example of chemical reactivity of halogens of group 17 as it decreases down the group from fluorine to iodine or astatine. So this was up for today's video, plus we have completed the chapter periodic classification of elements. To get to know about which chapter I am gonna start, subscribe to my channel and click on the bell icon.